Hi students, in this video we're going to look at how to calculate the expected value and variance of binomial distributions. Right after watching this video you should be able to calculate the mean, also known as the expected value. So mean, we use the mu symbol, or expected value is EX of a binomial distribution, or the variance using technology and algebraic methods. Right, key things to recall are binomial distributions, and remember your different values that come with a binomial distribution. N for the number of trials, P for the probability of success for one of your trials are the most important values to know here in this case. All right, so the mean or expected value of a binomial distribution, X, can be calculated using the formula. It's just N times P for my mean, which is mu, or expected value. Make sure you're used to using both of those different terminologies there. Yeah, it's just N times P, and that sort of makes sense intuitively. Right? So if we think about it, if we've got a multiple choice quiz where each question has 4 options, my probability of successfully guessing each of those, well, an answer correct from that will be 1 in 4. And let's say I have 20 questions that I'm guessing the answer for. The expected number, or the mean or average score we should expect if people are just guessing their answers, will be 1/4 of 20, which will be 5. And that sort of makes sense. We'd say you'd assume you get about 1/4 of the marks if you're just guessing them, because you're probably getting any one of the questions right as 1/4. So you'd assume you'd get about 1/4 right. And that's our expected value. Now the variance is going to be NP times 1 minus P. Remember, your variance just measures how spread out is your data, is what it's basically asking. So in this situation, we've got here the variance of our multiple choice quiz will be 20 times 1/4 times 3/4. We've just worked out that 1/4 of 20 is 5. 5 times 3 on 4 is 15 on 4, or 3.75. And that's a measure of how spread out my values and outcomes are. Now recall standard deviation, SDX, is just going to be the square root of the variance. You might be asked to do that one. Remember, it's just the square root of variance. That is not on your formula sheet, so you need to be told that. Or I would just encourage you to remember standard deviation is square root of the variance. All right, so in this example, we want to calculate the mean and variance of this binomial distribution. Okay, so n equals 10, p equals 0.2. So my expected value equals np, which equals 10 times 0.2, which equals 2. There's my expected value. So in this probability situation, we're expecting about 2 scores or 2 successes. Given the rate of success of those 10 options, we're expecting about 2 successes. All right, for my variance of x, that's np 1 minus p. So that's going to be 10 times 0.2 times 1 minus p is 0.8. We've already worked out 10 times 0.2 is 2. 2 times 0.8 equals 1.6. And there's my variance of this particular distribution. All right, let's do a question. The probability that a person has or has had the flu in Brisbane is approximately 16%. I just made that up. In a room of 24 people, calculate the expected number of people who have the flu and the standard deviation for this group. Okay, so part A, let's define our distribution. So we're going to say let x equal people have the flu, which is going to be modeled by a binomial distribution with 24 people in it. That's my number of people. And my probability of success is 0.16. I understand success in this case is not good. It means you have the flu, but bear with me. 16% is the probability of having the flu. All right, so in this case, EX equals NP, which is 24 times 0.16. And with our calculators, we work out that's 4.08. So in this room of 24 people, we're expecting about 4 people to have or have had the flu in this particular situation. All right, there's my expected value. Now I will need to work out my standard deviation. So my first step is to work out the variance. So my variance is going to be NP 1 minus P, which is 24 times 0.16. 1 minus 16% will be 0.84%, or sorry, 0.84 or 84%. Multiplying those together, we get 3.3864. And so my standard deviation of x is going to be the square root of that, 3864, sorry, which is going to be 1.8402 to 4 decimal places. Now, what that basically means, guys, is our standard deviation is in the same units as our expected value. So from our expected value of 4, if you have, about too high and too low, so 6 to 2, most of the, there's a very high probability that you're having between 2 and 6 people in that room who have had the flu. Just one standard deviation above and below, most of the data will be in that range. So the high probability will be that there's between 2 and 6 people who have the flu based off the standard deviation. All right, question that's got a bit more problem solving to it. So for the distribution, for the distribution, x is binomial with NP. The expected value is 6 and the variance is 4.2. Calculate the number of trials for this distribution. All right, so we don't know what n is. We don't know what p is. But the key thing we have to work out is n. We've been asked to work out the number of trials for this distribution. So let's write down the information we have been given. So EX, my expected value, equals NP, and that equals 6. We'll call that equation 1. My variance is equal to NP 1 minus P, and that equals 4.2. We'll call that equation 2. Now, how to solve this problem? Guys, notice first of all that in both my equations I do have NP. So NP here, NP here. So what I'm going to do is substitute equation 1 into equation 2 and just take NP out of this equation 2 and write in 6 instead. Okay, so sub 1 into 2, and I'll start up here. We'll get 6, 1 minus P equals 4.2. Divide both sides by 6. 1 minus P equals 0.7. 42 divided by 6 is 7, so 4.2 divided by 6 will be 0.7. Negative P equals negative 0.3. P equals 0.3. Excellent. Now that I've got P, I should be able to work out N. Let's go sub P equals 0.3 into equation 1, because that will just be easier. So 0.3n equals 6. N equals 6 over 0.3. Now, let's assume this is non-calculator. So if we've got a non-calculator question like this, how are we going to solve it? My best advice, guys, is we need to turn that denominator into a whole number. So what I'm going to do is multiply that by 10. I'll also multiply the top by 10. So the numerator Also, the denominator multiplied by 10, 0.3 times 10 will give me 3. 6 times 10 will give me 60, and then 60 over 3, I can work out that's going to be 20. So my number of trials will be 20, based off this information we've got here. That's more of a problem-solving, complex sort of question, but it's not too bad as far as the algebra goes. Just substitute your expected value NP in for NP in your variance formula, then rearrange the rest. Right, after watching this video, you should be able to calculate the mean and variance of a binomial distribution using technology or also algebraic methods.